Hello, my dear students. Am I audible and visible to all of you? Sorry, we got a bit late. Okay, so there are students who are watching and they are thinking about certain things. Okay. Am I clear? Well, fine. So, in the last class of electrochemistry, see, today's session, what we are going to do is today we are going to finish off with the entire electrochemistry thoroughly. So, we are going to finish off complete electrochemistry. Okay. And what we had talked about something called the conductance. And we had talked about something called conductivity. We are going to do all the entire thing about the electrochemistry, electrochemical cells, electrolysis. Today we are going to try to finish off entire electrochemistry chapter. We are going to try that does not mean that we are going to finish it off thoroughly. I didn't say that we are going to simply do it in any case. No, it is not the way. We are going to complete it properly, nicely, thoroughly. Okay, clear? So we have the 8 students watching. We have got the 7 likes. Could we increase the number of likes by 1 or 2? Many times the student asks me, why don't I have many students in my class? Well, I actually don't know why I don't have many students in my class. Perhaps the students are not able to understand what I am teaching. Okay, you have got your book copies. Today you have to make the all the notes. I'm going to dictate you the answers. I'm going to dictate you the notes. I'm going to dictate you the definitions. This is going to be one-to-one class. You are going to be taught as if you are in a physical class. Everybody is ready? So you may consider this is an elite batch where you are going to understand every statement. Is it clear? Fine. Of course, we are launching our plus batch also, but that doesn't mean that we are not going to do good in the this YouTube class. You know all about me. I don't need to tell you because there are only the regular students in the class. So you all know about me. My name is Anoop Vashishtha. I'm an MSc in chemistry from University of Delhi. 26 years teaching experience. Lakhs of students have been taught by me. So that's what you already know. So nothing great about it, nothing new about it. Okay, well, have I shared the session with the students? I don't think so. Has it been shared? Could you just share it with your students, to your friends? No, it has not been shared. So go ahead and please share it with your friends. पानी वानी ले लिया ना आपने सबने? Yes, here it is. So we have talked about something called the specific conductance, the kappa. Clear? That's what we have talked about, the specific conductance. Now, specific conductance is something like the conductance multiplied by the cell constant. No, I should say, like, what is it? We get The Ohm's law we had something like the resistance is equal to rho L by A. Then we had the G is equal to 1 by rho A by L. Then this G becomes equal to kappa A by L. So kappa becomes equal to G into L by A. Now this L by A is called the cell constant. Now the cell constant is represented by G star. So what we get is kappa is equal to G multiplied by G star, or you can say kappa is equal to G star by R, or you can say G star, that is the cell constant, is equal to kappa multiplied by R. So these are the units. Okay. Prerna, you teach brilliantly, sir. No one cares because we are lucky that you are more concentrated on us and you will soon have many students too. I don't know when I'm going to have many students, but at this moment I have very many students. Okay. So now, so this is what we have as the cell constant. Now this equation which we have, this is many times used. This is used many, many times. Now you need to remember it. So that is what we have as the rho. Now, what exactly is rho? What exactly we talk about the conductivity? Conductivity is the conductance of a unit cube of the conductor, or you may say in this case, when we talk about the conductivity, we are going to talk about the kappa here. And we had talked about one thing more, that whenever we talk about the conductivity of an electrolyte solution, we are going to talk about the alternating current. Alternating current that prevents the polarization effect, and so it can be used for a long duration. Fine. Clear? Now let's have a very simple question. Very, very simple question. We have a solution of zero point 0.1 molar potassium chloride, and we have another solution of zero point zero 0.01 molar potassium chloride. Now, potassium chloride is most often used for the conductometric measurements and conductometric studies. The reason is a different one. Of course, there is a logical reason. We are not just going to talk about any random reason. This has a particular logical reason. Now, we are having this. Now, let's say this is kappa 1. Let us say this is kappa 2. This is the conductivities. Now, please remember, when we talk about the questions of electrochemistry, you have to attend that class for the questions of electrochemistry. We are going to do the questions of the NCERT as well. We are going to do the questions of NCERT in the special classes. So when we talk about this kappa 1 and kappa 2, this is what we have. Here we have the question. Here we have zero point 0.1 molar of potassium chloride. Here we have 0.01 molar potassium chloride. We have kappa 1 and we have kappa 2. Then when we talk about the relation between them, I would like to ask you what would be the relation between the kappa 1 and kappa 2. The first option could be A, kappa 1 is equal to kappa 2. That could be the first option. Then the B option could be that kappa 1 is less than kappa 2. And then we have the C option, that is kappa 1 is greater than kappa 2. Clear? And D option is going to be a random option. What do you suggest? What would be the relation between them? Just give me the answer. What would be the relation between them? You have not given me the answer. Okay. So I got K1 is less than K2, K1 is greater than K2, and Priyanshu Ghosh says K1 is greater than K2, Tirthar says K1 is less than K2, Radhika Mittal says K1 is greater than K2. So we have got three. And Tirthraj Himanshi has said that K1 is less than K2. Okay, Tirthraj and Himanshi, could you give me an answer why K1 is less than K2? Now please remember this class, we have only how many? Five students watching. So five students, we are going to have this class absolutely in a proper two-way communication way. So you are going to give me the answer. Give me the answer why K1 is less than K2. Tirthraj, Himanshi, hello Ratnadeep Kore, Ratnadeep Kore. Ratnadeep, beta, you have to seriously watch the session and you have to reply to the question. Give me the answer, Tirthraj. Why is it so? Why is it so? Actually, the answer is K1 is greater than K2. The answer is C, not B. I'm giving you the answer. Why is it so? Now, what happens is that the kappa is actually directly proportional to the number of charge carriers per unit volume. Okay. Kappa is proportional to number of charge carriers per unit volume. Somebody said congratulations. Why? What's the meaning of congratulations? Today is not my birthday. Okay, kappa is proportional to number of charge carriers per unit volume. So as the number of charge carriers per unit volume increase, the kappa is going to increase because more amount of charge will be transferred per unit time. Clear? Tirthraj, Himanshi, have you got the answer? I believe your reason was that as we increase the concentration, then the number of charged particles actually decrease. Do you think so? No. Now, clear? So what we find is with increase in concentration, whether we have weak electrolyte, whether we have strong electrolyte, we have already talked about what the meaning of weak electrolyte is, what the meaning of the strong electrolyte is. So whether it be weak electrolyte, whether it be strong electrolyte, with increase in concentration, concentration of ions increase. So it is not a necessity that it's going to be proportional, but it is going to increase. Fine, clear? So kappa increases with increase in concentration of electrolyte. So that's one thing. That's a very straightforward thing that kappa increases with increase in concentration of the electrolyte. Now there is a term. That term is called infinite dilution. This term also we have done in the last class, infinite dilution. Okay. Now you may write the definition of infinite dilution. Just write it. I'm gonna dictate it. Infinite dilution by definition is the concentration at which, are you writing it, noting down? You have your paper pen with you? The concentration at which the electrolyte is completely dissociated, or you may even use the word ionized. So any further dilution does not increase degree of dissociation. Now, if degree of dissociation is alpha, then alpha is equal to 1 at infinite dilution. That is the meaning of infinite dilution. Now, one thing you need to remember that for infinite dilution, the state in which the solute concentration is considered to be zero and the activity coefficient to be unity. But Ratnadeep, that is a technical definition. But how can we consider the solute concentration to be zero? You can't actually. So this is a technical definition, a theoretical definition. The practical definition is the one which I have just told you. The activity coefficient is unity. Do you understand what the activity coefficient is? Clear? Now, this is alpha. Alpha is equal to 1. The degree of dissociation turns out to be 1. This is what we have as infinite dilution. Now, remember, it is practical for strong electrolytes. It is practical for strong electrolyte. But for weak electrolytes, this is a theoretical term. Strong electrolytes, why it is practical? Because strong electrolytes at a sufficiently dilute solution, they are completely dissociated. And that's the definition of a strong electrolyte. So for strong electrolyte, it works. But for weak electrolytes, it does not. So the concentration at which the electrolyte is completely dissociated for any further dilution to the degree of dissociation, that's what I wrote. Okay? Prerna, is it now clear? As we increase the dilution, the dissociation increases. Fine. But for a strong electrolyte, there is a limit when entire electrolyte is dissociated. And that is what we call as infinite dilution. Now, the concentration of something like 0.01 molar, 0.1 molar, 0.001 molar. Now, these concentration can be considered as infinite dilute for a strong electrolyte like potassium chloride. At infinite dilution, concentration of ions becomes directly proportional to concentration of electrolyte. So the concentration of ion becomes directly proportional. I didn't say equal. Like when we talk about something like sodium chloride dissociates to give sodium ion and chloride ion. So concentration of ions is equal to 2 into concentration of electrolyte. Clear? So that is what we have. Concentration of ions is equal to 2 into concentration of the electrolyte. That is what we have as the relation. Now, at infinite dilution, kappa will become proportional to concentration of electrolyte. Now remember, whenever in books we write concentration, we are not talking about concentration of ions. We are talking about the concentration of the electrolyte itself. So we simply write that kappa is proportional to concentration because the solute are not the ions, solute is the electrolyte. Here, anything you want to ask? I believe you are noting it down. And you have to note it down. Randeep Kore, what? It will double or what? I said it is that the concentration is being increased. I never said that the concentration is being made double. Why did you say the word double? Yes, it is going to be increased. It's going to be proportional. If we double the concentration of the electrolyte, the concentration of ions will also become doubled. Yes, it will. But I didn't use the word double. Clear? Here, when we say the concentration of the electrolyte, concentration of ions, the concentration of ions is double of the concentration of the electrolyte. Fine? Okay. Don't jump to conclusions. Just don't jump. And then you are going to get confused. You hear what I didn't say and you get confused for nothing. So that's what we have. So this is what we are talking about is infinite dilution, for infinite dilution. So what we can say that whenever we have the proportionality, we can make it into equality by using a constant for proportionality. So what we can say is kappa is directly proportional to concentration. So kappa divided by concentration will be equal to a constant. Now this constant we talk about as lambda naught, or we write it as lambda infinity. Lambda naught would mean the standard or limiting conductance. This is the limiting value. Limiting value means infinite dilution. Fine. So this is a constant. We call it a lambda naught or lambda infinity. Clear? Now, let's talk about units. The kappa could be having a unit of standard unit is Siemens meter inverse. That is the standard unit of kappa. Concentration we can have as molarity or normality. We can have the concentration as molarity or normality. Molarity would be moles per decimeter cube, or you may call it as mole liter inverse, that is moles per liter. And when we talk about normality, it is equivalence per decimeter cube, or you can say equivalence per liter. So these are the units. Fine. So what we do is, and kappa could be even taken as Siemens centimeter inverse. Well, it's up to you whether you want to take it in CGS unit, whether you want to take it in SI units. But in chemistry, most often we are using the CGS unit because our cell constant also turns out to be in centimeter inverse. Clear? Now, having talked about this, when we talk about this kappa, Siemens meter inverse, let us see what the unit of this constant turns out to be. So we have kappa upon concentration is equal to lambda infinity or lambda naught, whichever you all call it. So we have kappa in, let's first of all do SI units. Well, it does not make a difference. Let's first of all do in SI units. So kappa is taken in Siemens meter inverse. Okay. Now we have the concentration. Concentration for the time being, let's talk about molarity. Moles, molarity. So we have mole decimeter cube. Now you need to understand that a meter cube is equal to 1000 decimeter cube. So the numerator has meter in it. Either we want to convert it into centimeter or we want to convert it into meter. We generally don't have decimeter as a unit. So let us convert the decimeter cube into meter cube. So decimeter cube is equal to meter cube upon 1000. Clear? So to convert decimeter cube into meter cube, we have to multiply by a factor. That is, factor would be meter cube divided by 1000 decimeter cube. So what we do is, this undergoes multiplied by meter cube upon 1000 decimeter cube. Clear? Now, I'm just going to get it here. Now, that will be equal to lambda infinity. Now, what's going to be the units here? Now this decimeter cube and decimeter cube are going to get cancelled out. Meter cube is going to become meter square. Mole inverse is going to remain there. So we are going to get it in Siemens meter square mole inverse. Siemens meter square mole inverse. That will be the unit. Now since it is per mole, this is termed as molar conductivity. This is molar conductivity. Okay. Here we are taking at the unit as Siemens meter square mole inverse. Any confusions? Now 1000, this part is a conversion factor. Have you noted it down? Ananya, hold on, beta, hold on. Hold on. Have you copied it down? Now, let us do it another way. We have copper in Siemens centimeter inverse. Okay. And we have the concentration again in mole decimeter cube. Now, 1 decimeter cube is equal to 1000 centimeter cube. Now what I need to do is I want to convert a decimeter into centimeter cube. Okay, so the conversion factor is going to be 1000 centimeter cube divided by decimeter cube. This is going to be the conversion factor. Okay. So here it is going to be into 1000 centimeter cube per decimeter cube, and that's going to give us lambda infinity in Siemens centimeter square mole inverse. Now again, this is the conversion factor. I'm perfectly fine, Siba. Okay. So as you can very well see that if we want to convert it into meters, it will be meter cube by 1000 decimeter cube. And if we want to convert into centimeter, sir, then in that case, it's 1000 centimeter cube per decimeter cube. So 1000, the factor is going to be numerator or denominator. It depends on what you need to convert into what. What is the value of the cell constant given in? Is it in SI units or is it in CGS units? So you need to understand this is what we have as a conversion factor. Most often the books don't mention it, whether it is centimeter cube or decimeter cube, but NCERT has done it. So this can be actually asked in your examination. So that is what we have as kappa. Now, this is what we again have the molar conductance or molar conductivity. Okay, so this is what we call as molar conductance or molar conductivity. Yeah. Write the definition of molar conductivity. What is the definition of molar conductivity? Molar conductance. Molar conductance. It is the conductance of one of a solution containing 1 mole of the electrolyte. It is the conductance of solution containing 1 mole of electrolyte present between large enough electrodes. That means those electrodes should be able to accommodate the entire solution. Alisa, hello, how are you? Welcome to the class. I'm perfectly fine. How are you? Okay, so that's what we have as molar conductance, the units you can define. Now, this molar conductance is going to be proportional to the number of ions per mole of the electrolyte. Molar conductance depends on number of ions per mole of electrolyte. It does not depend on number of ions per unit volume because volume has been cancelled out. So it is always going to be per unit volume. So it does not make a difference here. So here we don't need to say per unit volume. Even if per unit volume increases or decreases, does not make a difference. What makes a difference is per mole, the number of ions are being increased or decreased. Ratnadeep Kore, did you understand something? Or have you read something wrong? Or you want to just find the faults? What we are talking about, did you see what we are talking about? We are talking about the limiting value. We are talking about infinite dilution. And infinite dilution, it does not change per mole, does not change with concentration. Sumit Roy, we are talking about infinite dilution. Remember that. Is it clear? At infinite dilution, yes, it is a constant. So we are talking about the concentration at infinite dilution. We are talking about lambda naught. Okay, am I clear with that? Now, so we have just talked about molar conductance depends on number of ions per mole of the electrolyte. Okay, fine. It is maximum and unchanged at infinite dilution. Lambda naught constant at infinite dilution. Vaibhavraj Pathak, beta Akash Baijus. I should not say any word, isn't it? Clear? I'm here with you. I'm going to teach you. I'm giving you all the explanations. So be with that. Fine. Let's not get along with those things which are not very pleasant. Okay. So lambda naught remains a constant at infinite dilution. Is that clear? Okay, Priyanshu? Okay. Now, one thing more. We can have the kappa in Siemens anything, length inverse, whatever it is, meter inverse or kappa in Siemens centimeter inverse, whatever way you want, you can have it in that manner. Okay. Now, what you need to understand is we can have concentration as equivalents per decimeter cube. Now, lambda not. Instead of lambda molar, it is going to become lambda equivalent. Lambda equivalent has a unit of Siemens Siemens centimeter square equivalent inverse. Now, this is what we call as equivalent conductance, or you may call it equivalent conductivity. Is it clear? Again, at infinite dilution, it becomes a constant. So at infinite dilution, this becomes a constant. Whoever has not liked the session, please go ahead and like it. We have 15 people watching the session and we have got only 12 likes. That is not good. So that is what we have as equivalent conductivity. Now, there are so many people who says that, sir, the lambda is not a constant. I perfectly agree with them. Lambda is not a constant if the concentration is not infinite dilution. Okay. So at any other concentration, that means other than infinite dilution, any other concentration, then kappa is not actually proportional to concentration. It is not actually proportional to concentration. Fine. Kappa increases with concentration. That is not a problem. But it is not increasing directly. Let us say we increase the concentration twice, then kappa would increase. Maybe it becomes 1.8 times. It is not necessary that it's going to become double. It might become 1.88 times. Maybe it becomes 1.5 times. Maybe just 1.1 time. It is going to increase, no doubts. But it's not going to become exactly twice or something like that. Okay. So kappa upon concentration is taken as lambda. Now, this is not a constant, but changes with concentration. Molar conductivity is large for large ions. Sumit Roy, beta, molar conductivity, what you are talking about, you need to tell me how you are considering the ion size. Are you considering the size of the hydrated ion or you are considering the size of the unhydrated ions? That makes a lot of difference. In fact, it becomes the opposite answer. So just be very clear what you are asking. Molar conductivity is large for large unhydrated ions because their hydration is low. So their effective value, the effective size actually turns out to be smaller. For large hydrated ion, molar conductivity is actually low. Got it, Sumit? So here, this is not constant. This is not a constant. Now, when we talk about degree of of dissociation. Now, degree of dissociation works differently for strong and the weak electrolyte. For weak electrolyte. Now, I'm not going to go into the derivation of that. Do you want me to go into the derivation? Let's see. Let's see. Let's go on the derivation. We don't have any lack of time. That derivation would be useful in even equilibrium. Let us say we have something like CH3COOH in equilibrium with H plus CH3COO minus. Now here we consider it as 1 minus alpha. This is going to be alpha. This is going to be alpha. We multiply it by concentration. It becomes C into 1 minus alpha. Now alpha is the degree of dissociation. This is C alpha. This is C alpha. Okay. Now K, the equilibrium constant, is equal to concentration of H plus into concentration of CH3COO minus divided by the concentration of CH3COOH. Now that turns out to be C alpha multiplied by C alpha divided by C into 1 minus alpha. Is this clear? Now that means K is equal to C alpha square upon 1 minus alpha. Neglecting alpha compared to 1. We are talking about weak electrolyte. We are talking about weak electrolyte. K is equal to C alpha square That means alpha is equal to under root of K by C. Is this clear? Ananya, we have done the derivation. This is the derivation. Any kind of confusions? So if the concentration is made 1 by 100, alpha becomes 10 times. So there is a very different difference. So this is for the weak electrolyte. Now, if I talk about the weak electrolyte, lambda is proportional to number of ions per mole. Lambda is proportional to number of ions per mole. So lambda is proportional to alpha. That is degree of dissociation. So what we get is lambda is proportional to under root of K by C, or you can say lambda is proportional to 1 by under root C. Is this clear? Why did we multiply with C? Because we don't have the concentration as 1 mole per liter necessarily. Okay, Priyanshu, we want the number of ions, we want the concentration of ions. So when we are talking about 1 minus C, we are taking the concentration as 1. 1 minus alpha, we are just taking the concentration as 1. So the concentration is not necessarily 1. So that is why we multiply by concentration to get it from the given concentration. Okay, is this clear? Now if I make the graph, now here I plot the lambda, and here I plot under root of concentration. Under root of concentration. So the graph is actually of 1 by x versus x. When we get the graph of the inverse, this is how we get the graph. This is the graph of the weak electrolyte, that is acetic acid. Clear? So the molar conductance of the weak electrolyte changes drastically with concentration. There is a drastic change in the molar conductance of the weak electrolyte. Okay, Sumit Roy, everybody clear? Now, this is for the weak electrolyte. Now, let us talk about the graph for the strong electrolyte. How does the strong electrolyte change? strong electrolyte. The strong electrolyte, they follow an equation called Debye-Huckel-Onsager equation. Now the equation is given in NCERT, but the name is not given. So equation is in your course, but not the name. The Debye-Huckel-Onsager, I generally remember it as ABC. It is lambda is equal to lambda naught minus B under root C, where lambda is molar conductance, or you may call it equivalent conductance. Molar conductance does not make a difference in this case. Lambda naught is the limiting value. Limiting value is at infinite dilution when it is completely dissociated. B is constant depending on nature of electrolyte. Nature of electrolyte would mean that it is 1:1 electrolyte like sodium chloride, 1:2 electrolyte like magnesium chloride, or it is 2:3 electrolyte like aluminium sulfate. Depends on that. So what kind of electrolyte it is. And obviously C is the concentration. So that is what we have as the units. Clear? So if I talk about this, this is a linear equation with a negative slope. It's an equation of a straight line with a negative slope. Arman Ali, what is out of syllabus? Okay. Now, if I use this value, this was the graph for a strong or weak electrolyte. Now, to talk about the graph for a strong electrolyte, it would go like this. This is how the graph of a strong electrolyte goes. Straight line with a negative slope. And here it can be extended to give us the lambda naught, the limiting molar conductance. So that is how we get the graph of the conductance of a strong electrolyte and the weak electrolyte. Okay, having talked about that, I hope you have downloaded it or you have copied it down. Now, once we have talked about this, let us talk a few simple things, very simple things. A question. We have 1 molar KCl. Okay. Alpha, I'll say 100% dissociated. 1 molar KCl 100% dissociated. Now, KCl dissociates to give K plus plus Cl minus. Now, if this is 1 molar, this is going to be 1 molar, and this is going to be 1 molar. Clear? So we have 2 molar ions. Okay? 1 molar KCl is 100% dissociated. 1 molar KCl when dissociated gives 1 molar of K plus ion and 1 molar of Cl minus ions. So it is going to be 2 molar ions. Any confusions with that? Okay. Now we have 10 molar KCl, which is, let us say, 90% dissociated. So we have 10 molar KCl, which is 90% dissociated. So we have KCl. Now this is 10 molar. Now this is going to dissociate to form K plus, and it is going to dissociate to form Cl minus. Now since it is only 90% dissociated, this K plus is not going to be 10 molar. It is going to be 9 molar. And Cl minus also is going to be 9 molar. Any confusions here? Now this is going to have 18 molar ions. Fine. Now let us say this is the solution A. Now let us say this is the solution B. Fine. Let us have a question. Which of these solutions has more ions per unit volume? Which of these solutions has more ions per unit volume? Okay. Options are A, B, both same, or insufficient data. Give me the answer. Now, this is an important question. You need to know it. A, B, or insufficient data? Both same? Give me the answer. Sumit Roy has given the answer. What about others? There are 9 people here. I've got only one answer. Okay, Ananya? Sumit, don't give me the answer twice. I have seen the answer. Prerna, Titraj. I hope you have read the question correctly. Radhika. But I believe when we talk about molarity, we are talking about per liter, isn't it? Okay, Priyanshu, ठीक है. Uranic C, both same. Arman Ali B. Okay. Arman Ali, give me the answer only once. I'm seeing the answers. Okay. So everybody has given me the answer. Some people have given, only one person has given the B answer, one has given the C answer, rest of all the people are giving the answer as A. Okay. Can anybody tell me what is the meaning of 1 molar? What is the meaning of 1 molar? 1 molar means 1 mole of the substance per liter of the solution. Clear? This has 2 molar, that is 2 moles of ions in a liter. This is 18 molar, that is 18 moles of ions in 1 liter. Do I need to tell you that 18 is greater than 2? Sumit Roy, if you know molar means n moles 1 liter of the solution, don't you know that this is 2 moles in 1 liter of the solution? This is 18 moles in 1 liter of the solution, and still you are saying that A has more number of ions per unit volume. And then you say, I'm going to confuse you. Did I confuse you? What was confusing here? Just read it. What is confusing? In fact, I have written the answer. I have actually never, not even asked you a question. I have given you the answer. I have actually given you the explanation, and then I'm just asking you what I have written. What did you get? Sumit, what did you get? Ananya, what? Sorry. Why did you make a mistake? Tell me. And please don't be disheartened, don't be feel bad, because this is a question. Why do I ask this question? If I knew that everybody is going to give me the right answer, I would have not asked the question. Why did I ask this question? Because the students make a mistake. अगली बार गलत नहीं होगा अनन्या. I'm not going to ask you अगली बार this question. Why do you say sorry? Tell me. Why did you commit this mistake? ये गलती हुई क्यों? Don't be sorry. I gave you this question because I knew you are going to make a mistake. So don't be sorry about it. Tell me, why did you make a mistake? Did you not read the question? क्या ये गलती होनी चाहिए थी? Remember, we have a class at 4 p.m. again. And at 4 p.m., we are going to begin with this session and we are going to finish off the chapter. कोई मुझे बताएगा ये गलती हुई क्यों? So the answer was A. Clear? The answer was A. Just a minute. नहीं Ananya, I am not disappointed with you. I'm not disappointed with you. This was a question, this was a tricky question. You need to understand. Whenever I ask you a question, however simple it might appear, I ask you a question because I know the students make a mistake. And that is what the 26 years of experience means. Okay? So A has more number of ions per unit volume. As you can very well see that when we increase the concentration, even if the degree of dissociation decreases, the actual concentration of ions increases. So kappa is more for B because kappa is proportional to the concentration of ions per unit volume. Okay, the number of ions per unit volume. Is this clear? So as you can very well see, kappa increases with the concentration. Arman, doesn't make a difference Ananya Bengali hai ya nahi. The only thing which makes a difference is you are a student and she also is a student. Now next question. Which of these solution has more ions per mole? A, B, both same, or again insufficient data? Pick it up. Give me the answer. Now, the class we are having at this moment, you can't even have a better class in an offline institute. Perfect. The answer is A. Because here we have 2 mole ions per mole. In B, we have 1.8 mole ions per mole. So, lambda decreases with concentration. And then it's not an insufficient data. It is the complete data because here we know that 1 molar gives 2 molar ions. Here we know 10 molar gives 18 molar ions. So 1 mole will give how many moles of ions? It's easily calculatable. Sumit, I wrote the question. I wrote it. You are asking me what is the question. Okay. पानी पीने चले गए थे क्या भाई? So lambda decreases with concentration. Fine. Now let's have, you would be saying, sir, एक क्वेश्चन और दो, आप गलती नहीं करेंगे, सर एक क्वेश्चन और दो. Okay, fine, I'm giving you a question. ठीक है. 0.1 molar Na2SO4. Okay. And 0.1 molar NaCl. 100% dissociated. 100% dissociated. Option A. Na2SO4 will have higher lambda but lower kappa. Okay. B. NaCl will have higher lambda but lower kappa. C. NaCl will have higher lambda as well as kappa. D. Na2SO4 will have higher lambda as well as kappa. So the one which has more number of ions per mole will have a higher value of lambda. The one which has more number of ions per unit volume will have the higher kappa. So give me the answer. So we have got the answer A, D, D. Somebody said C also. They have eliminated the question. Okay, give me the answer. We have Na2SO4 dissociating to give 2Na plus SO4 2 minus. If this is 0.1, this is going to be 0.2, this is going to be 0.1, total is 0.3. Okay, and if we have NaCl, NaCl dissociates to give Na plus Cl minus. This is 0.1, this is 0.1, this is 0.1. So this is going to become 0.2. Quite obviously, only single answer is going to be there, Sumitra Roy. So sodium sulfate has 3 ions per mole and it has 0.3 molar concentration of ions. The answer was D. Sodium sulfate has more lambda as well as kappa. So it is not a necessity that the species which has more of kappa has to have a lower lambda. Is it clear? Any kind of confusions here? Okay, so that's what we have as lambda and kappa. Now to get along with something called Kohlrausch law of independent migration of ions. Kohlrausch simply stated that the ions move independent of each other at infinite dilution. Okay. Now, conductance is additive. Conductance is something like that. We have a number of students who want to carry books. So if one student is carrying a book, another student is carrying some book, the third student is carrying some book, the total books are carried as simply the addition of the books carried by each person. In the same manner, if some particular ion carries some charge, the other ion carries some charge, the total charge carried is the sum of the charges carried by all the ions. Okay, conductance is additive. That is total conductance is the sum of all ions. Maybe identical, maybe different, whatever it might be. Okay. At infinite dilution, ions move independently. Okay, fine. So at infinite dilution, the molar conductance of any electrolyte is the sum of molar conductance of its ions. Is it clear? Hello, Nilanjan. Okay. Who all have not liked as yet the session? So that is what we have as the Kohlrausch law. So let's say we have certain examples. We have NaCl. Now NaCl dissociates to form Na plus and Cl minus. So we have lambda naught of NaCl. Now lambda naught of NaCl will be equal to the lambda naught of Na plus lambda naught of Cl minus. Now as you can very well understand that this is the lower lambda case, lowercase lambda, and this is the capital case lambda. So the capital case lambda is denoting the entire electrolyte while lowercase lambda denotes the individual ions. Any confusions here? So here we have like K2SO4. Now K2SO4 gives us 2K plus SO4 2 minus. So if somebody talks about lambda naught of K2SO4, that will be equal to lambda naught of K plus, but here you need to multiply it by 2 because the 2 moles of ions are being formed per mole of the electrolyte plus lambda naught of SO4 2 minus. If I have something like Al2SO4 whole thrice, now when this dissociates, it's going to give me 2Al3 plus thrice of SO4 2 minus. Now the lambda naught of Al2SO4 thrice is equal to twice of lambda naught of aluminium 3 plus thrice of lambda naught of SO4 2 minus. Anya, what exactly do we need to repeat? Have you noted it down? Now, this simply means that if we have an electrolyte AXBY which dissociates to form X of A Y plus Y of B X minus, then lambda naught of AXBY is equal to X of A Y X of lambda naught A Y plus Y of lambda naught B X minus. Yes, Sheetal, I remember you. What is your score? You never told me your score. Your younger brother also joined the session. So we have the Kohlrausch law of independent migration of ions, the molar conductance of any electrolyte at infinite dilution is the sum of limiting limiting molar conductance is the molar conductance at infinite dilution. Limiting molar conductance of its ions multiplied by the stoichiometric coefficient. So Sheetal Chand, where are you getting the admission? Could you please send your mark sheet, the scorecard? That would be nice, really nice. And we would be able to arrange an interview with you. Okay, Sheetal? So me and Sachin sir are going to conduct an interview for our individual channel. Okay? Please send me your scorecard. Okay, so it's ions multiplied by the stoichiometric coefficients. Clear? Now, this law is applicable to all electrolytes, but can be actually verified for only strong electrolyte. Can anybody give me the reason? Ananda, which is the first one? It simply says that we are going to sum total of the electrolytes. What is the first one? Can anybody tell me why it can be verified only for the strong electrolytes? Why can't we verify it for the weak electrolytes? Why can't we verify for a weak electrolyte? The only simple reason is infinite dilution only for strong. Infinite dilution does not work for the weak electrolyte. It works only for the strong electrolyte. Perfect, Priyanshu. We have given the right answer. Clear? So that is what we have as the Kohlrausch law of independent migration of ions. Now, once we have talked about the Kohlrausch law of independent migration of ions, now let us get along with the utility of Kohlrausch law. Clear? I am perfectly fine, Harsh. जीते रहो, कैसे हो आप? Okay, let's get along with the utility of the Kohlrausch law. What exactly is Kohlrausch law? How we can use it? Let us say we have an equation. We have CH3COOH. Now this is in equilibrium with CH. I should not write it like we. I should write it H plus plus CH3COO minus. Now this is an equilibrium. Okay. It is not completely dissociated. This is at equilibrium. Now let us consider, think over at infinite dilution. At infinite dilution, CH3COOH should get converted into H plus and CH3COO minus. That it should get converted into. Now here, lambda naught of C lambda naught of CH3COOH will be equal to the lambda naught of H plus lambda naught of CH3COO minus. Right. Now let's do a little thing. Ananya, Sheetal studied with me. That's not a problem, but Sheetal is not sending me the scorecard until unless I see the scorecard sent by Sheetal. Till that time, I cannot verify the claims, isn't it? Sheetal, send in your scorecard. I'm going to upload it on my Plus class and I'm going to show it to every student. Okay? Send in me your scorecard. Okay? Now we are going to get along with certain simple thing. Now, what are those simple things? Let us say we have something like NaCH3COO. Now, this is what we call as sodium acetate. Sodium acetate is a salt that gets completely dissociated to form Na plus CH3COO minus. And here, the lambda naught of NaCH3COO is equal to lambda naught of Na plus lambda naught of Na plus lambda naught of CH3COO minus. Clear? And then we have lambda naught here. Another species. Let us say we have HCl. Now HCl dissociates to give H plus Cl minus, and lambda naught of HCl will be equal to lambda naught of H plus lambda naught of Cl minus. And then we have something like NaCl. NaCl is Na plus and Cl minus. And here we get lambda naught of NaCl is equal to lambda naught of Na plus lambda naught of Cl minus. Good gamer, beta, please have concentration on the session rather than talking to the students. Sheetal, you can always learn it from us on this particular channel. Okay? This channel is working without any problem. We are going to have the test, Ananya. We are going to have the full syllabus test also. You know I can have it, and I'll be having it. Don't worry. So this is what we have as Na plus and Cl minus. Now this is NaCl. Now what I do is I add. We have NaCH3COO plus HCl minus NaCl. Now that would be Na plus CH3COO minus plus H plus Cl minus Na minus Cl minus. Okay. Now if I take it in this manner, what I get? That Na plus get cancelled out, Cl minus gets cancelled out, and we are left over with CH3COO minus plus H plus, which represents CH3COOH. Any confusions this one? I have not yet created the special class, but I think I should be creating it. We can do the questions of conductance at least. In the same manner, if I take it lambda naught of CH3COONA, add to it lambda naught of HCl, and subtract from it lambda naught of NaCl, I would be getting the lambda naught of CH3COO minus plus lambda naught of H plus lambda naught of Na plus lambda naught of H plus lambda naught of Cl minus lambda naught of Na minus lambda naught of Cl minus. Okay. So we talk about this lambda naught of Na plus, and lambda naught of Na plus gets cancelled out because the conductance are additive, so they are subtractive as well. Now this is Cl minus, this is Cl minus. So this becomes equal to lambda naught of CH3COO minus plus lambda naught of H plus, which is equal to the lambda naught of CH3COOH. So that would mean lambda naught of CH3COONA plus lambda naught of HCl minus lambda naught of NaCl is equal to lambda naught of CH3COOH. So that simply means we can find limiting molar conductance of weak electrolytes using a combination of three appropriate strong electrolytes. Is this clear? Could anybody give me a combination of electrolytes for, and remember, water is not a strong electrolyte, for maybe ammonium hydroxide? So could you give me the combination for lambda naught of NH4OH? Give me the three electrolytes quickly. Answer combination. I need three electrolytes, Prerna, not one. Siddharth Singh, H2O is a weak electrolyte. I just told you that H2O cannot be used. We need strong electrolytes. H2O is a weak electrolyte. NH4OH is NH4Cl minus NaCl plus NaOH. Right, Priyanshu? Okay, now let me give you a combination. Lambda naught of BaCl2 is X. Okay. Lambda naught of BaOH twice is Y. And lambda naught of NH4Cl is Z. Yeah. Can you give me the lambda naught of NH4OH in terms of X, Y, Z? Give me the lambda naught of NH4OH in terms of X, Y, and Z. Give me the combination in terms of X, Y, and Z. BaCl2 is Ba2 plus 2Cl minus. BaOH twice is Ba2 plus twice of OH minus. NH4Cl is NH4 plus Cl minus. And what do I exactly need? I need NH4 plus OH minus. So to get OH minus, I need to have 1 by 2 of this. Okay. To get this, I need to get 1 of this. So it is going to be Z plus Y by 2. Now I have half of barium 2 plus and 1 of Cl minus. So it is minus X by 2. Clear? Ananya, the answer is different. I have written the answer on the board. Is it visible to you? Ananya, I need 1 of NH4 plus. That is obtained from lambda naught of NH4Cl. I need only one OH minus, but there are two. So I need to multiply it by 1 by 2 to get 1 of OH minus. And then I need 1 of Cl minus and half of barium 2 plus. Because here I have made it half. So I need to get half of BaCl2. Did you get it, Ananya? There are only 3 watching. Where are the others? Maybe all the people have left because of the issue in the data. Today you have 3 plus 2 plus 3, 8 hours of class. Do you have the data for that? Okay, now certain things more. We can find the degree of dissociation of weak electrolytes. Now, lambda molar is proportional to alpha, okay, the degree of dissociation. Now, lambda not molar is proportional to 1. It's a constant. So, if I get the molar conductance experimentally, this one is experimentally, and divided by the standard molar conductance from Kohlrausch law. That would actually give me alpha. So if anybody has any doubt with data, go ahead and arrange it. I would really appreciate if you will be able to get a broadband connection. If not, still you have to manage somewhere. That's the only cost that you need to incur, the data cost. Clear? So this is we can do with the degree of dissociation. Now, since we have very few students, I would like to ask you one thing. Let's talk about the vote. Nobody is here. Only 5 students, 4 students watching. Okay. The question is, should we do NCERT of conductance or start with electrochemical? Tell me. Tell me quickly. Should we do NCERT of conductance or should we start with Okay, give me answer. Okay, we are doing NCRT conductance because that will complete the topic thoroughly. So we will just finish off entire thing of conductance, whatever is there, that will be thoroughly completed. Okay, just let me get along with it. What exactly is happening here? Okay, 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 okay. I clear. I'm clear, 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 clear. The new NCRT, it is the second chapter. Yeah. Here. So here we have the book. Have you got your book? You can get your new book, you can get your old book. Both the books have the electrochemistry chapter. So here we are going to start over with the conduction. Okay, should we begin over with it? Everybody here? We are starting with NCRT. Tell your friends also that we are going to discuss about NCRT. We are going to take some time with that. And we are going to finish off with conductance thoroughly today in this particular session. In the next session, we are going to talk about electrochemistry, electrochemical cells. No problem, Sandhya. You can have the old one. Just open up the electrochemistry chapter. In the old NCRT, the book chapter is number 3. In the new NCRT, it is a chapter number 2. Okay? Got your NCRTs? Fine. So here we have the we do not need to talk about this Wheatstone bridge. No, we do not need. Not required. We do not get the question of the Wheatstone bridge in chemistry. We get the question in physics. Okay. Now, this is an important equation. We have already done that. That's Ohm's law. And we have rho L by A. Okay. Now that's resistivity. Just read through it, the NCRT. If anything you want to ask, go ahead and ask me. Now this is the conversion factor. This is the conversion factor. Whoever has not liked the session as yet, go ahead and like it. And what's happening here? Set the quality at least 480p. You can even put it as 1080p because I'm telecasting at 1080p. Now this is an important equation again. This is going to be used in many of the questions. The SI units of this is Siemens. This is represented by symbols S. Now just don't confuse it with entropy. Okay. And it's equal to ohm inverse. Sometimes we write it as ohm, mho, this way, and it's also written it upside down. Is this clear? So that's what we have written. This is the definition of conductivity. And this you need to understand. This is to be remembered. We have talked about the different conductors. What are the different conductors we have? Conductors, insulators, semiconductors. Now, this part, remember. Just remember this part. CuO also is a semiconductor. Cupric oxide is a semiconductor. Now, this part is not there. This has not been asked at all as yet. This is what we have already seen. Now, that is also an important part. They may ask you a question having all these options, and one of these things would be there, what it does not depend on, or what it depends on. Clear? Bit of buffering at this moment, but now it would be okay. Yeah, now it's okay. There was a glitch from, I think, YouTube side. My side is perfectly fine. So, now these are the conductivity cells. We talked about that conductivity cell. You can just read through it. This is not going to be making any difference. This is already done. Okay. Beta, this was not the lag from my side. This was the lag from YouTube side. My side was perfect. Maybe YouTube is getting bored. So this is what we have. Now this is L by A cell constant. This equation again is important. not to learn. This is not supposed to be learned, but you need to just know that molar conductivity changes with the concentration, with dilution. Okay, this is change with dilution. Now, this Wheatstone bridge, you don't need to bother about it. Nobody's going to ask. Clear? So, as you have understood, I have also told you that we are going to use the alternating current. We are going to use alternating current. Clear? Remember, at 4 p.m., we are going to start with electrochemical cells, the electrochemistry. Okay? This is what we have as molar conductivity. So remember, we are using the word conductivity rather than conductance. So this is actually the formula. Yeah. So this is the conversion factor, which we did today. Tirthraj, class is going on. What happened? Only one watching here? No, the class is going on. रिफ्रेश कर लो एक बार. Okay. This again is an important conversion factor. Now just read this question. ये लिख के सॉल्व करो. See, I have only few students on the YouTube. I believe there are only 5 students here. So I believe I can make you write it. It will be like a personal coaching to you. Write it. Take your time, write it. We are going to finish off this chapter, this particular topic thoroughly today. Anyone has any kind of doubt, simply ask it. Done? Any kind of doubts here? The solution is right here. Okay, 2.5. Read through it. Ask me if any kind of doubt is there. Read it, write it, solve it. Everything should be clear. Every symbol, everything should be clear to you. Take your time. Nothing, no hurry. Ananya, have you written it out? Not just copied it, written it with understanding? Because I just don't want you to waste your year. I just don't want you to waste your year. I won't let you waste your year. Because many a time students feel that they know it. हाँ हो गया सर हो गया हाँ हाँ आता है सर देख लिया नो प्रॉब्लम सब कुछ समझ में आ गया I am not going to take your word for it. No, I'm not going to take it. You have to write it. Is it clear? There are only few students. Only few students. And I'll make sure that each of you gets 180 on 180 in chemistry. Then the next question also. This question, example 2.5. By writing in your note copy. Well, once the class gets over, I want you to send me your notes. Whatever notes you have made, create a PDF of that and send it to me on either Telegram or WhatsApp group so that everybody can see what notes you have created. See, Prerna Rajput. Now she's asking me explain this question. What were you doing till now? The electrical resistance of a column of this much mole per liter. This is the concentration of sodium hydroxide solution of diameter 1 centimeter. Now this is by using that you can find the area of cross section A. Clear? Length 50 centimeter. This is L. So this is what you are given as R. Clear? Using the R you can find the rho. Fine. So this area is here. Length is here. We get the length in meter. Area we have got it in meter and we have got the area in centimeter. So we can get the cell constant in centimeter or in meters is our wish. And similarly, we are going to get conductivity either in, say, Siemens meter inverse or Siemens centimeter inverse. Bap, it's your wish. Getting it, Prerna? Bapi, the idea is not good because BDS is not something that you can just simply sit around and do it. Either you do it or you don't do it. No use. Because if you are going to put your feet in two नाव, दो नाव में सवार होगे तो डूब जाओगे. अगर बीडीएस करना है तो ढंग से करो, वरना एक साल बर्बाद. नीट की तैयारी के चक्कर में बीडीएस बर्बाद हो जाएगा. वो तो बर्बाद होना ही है. तो व्हाई डू यू वांट टू डू इट? Ananya, first of all, finish off the NCRT. Then you can read throughout. Is that okay? So this is how we can do this particular question. Just go through it. Any doubts you can have. The variation and molar conductivity with dilution, that is concentration. I think we have just done it today itself. Send it to me on the Telegram channel. You can send it, I believe. Telegram group. Okay. You will have to follow what I say. And I'll assure you that you are going to. That is, I told you, you have to make the notes. So there's no problem. There should not be any problem in sending the photograph of those notes. Okay. You can compare the notes with other students as well. And I believe you have joined the Telegram group. You have all. Okay. Any doubts with that? This particular graph we have already understood, discussed. See, lambda is not equal to K. You have to see the condition. 1 mole of electrolyte kept between two electrolyte, area of cross section A and the distance of unit length. Unit length. Okay. L is equal to 1 and A is equal to V, volume containing 1 mole of electrolyte. That's it. This is the limiting molar conductivity that we talk about as lambda naught or lambda infinity. Remember, for strong electrolytes, lambda m increases slowly. This can be asked in the exam. Ananya, you have to make notes. Don't tell me that you read from the modules. That is why you don't make the modules. This is going to cost you a lot. So you have to make the notes. You read it or not, I don't care. But you have to make the notes while the class is going on. What are you going to do? When I dictate you something, when I'm writing something, what are you doing? Wasting your time? Don't. Write it. What is going to happen? You are going to waste one copy? Fine enough. And you won't be able to write all the extra points in NCRT. So this is what we have as Debye, Huckel, Onsager equation. This is the Debye-Huckel-Onsager equation. हाँ शिखर सोमावंशी assertion reason है. And this is, you need to understand the value of constant A for a given solvent. This was the question in the NEET 2023. Depends on the type of electrolyte, that is the charges on the cation and anion produced on the dissociation of the electrolyte in the solution. Thus, NaCl, CaCl2, FgCl2 are known as 1, 1, 2, 1, 2, 2 electrolytes. Strictly all electrolytes of a particular type have the same value for it at a constant temperature. Is this clear? Fine, this graph is not going to be there in your exam, so there is no need to create the graph. Can you understand this part? Not to learn. But you need to understand one thing, H plus, OH minus have exceptionally high molar conductance in water. H plus and OH minus have exceptionally high molar. Clear? Now, weak acids, you can say lambda m increases steeply. Lambda m for weak electrolytes is obtained by using Kohlrausch law of independent migration of ions. Okay. Now, this is very important. That's what I told you. Clear? This also you need to learn. You're talking about 180 out of 180 in chemistry. I'm not talking about 160. I'm not talking about 150. I'm not talking about leaving any chapter. So if you want to really get 180 out of 180, then in that case, this is what you are supposed to do. Okay. Have you done this example? Written it? Create the PDF using the document scanner and send it. Why you have to write the question answers also. Example 2.8. Do it. Write it and do it. When are you going to do Prerna? When? You have to do it now. Do it now. I got only 5 students. I have to get the 5 students getting 180 out of 180. You have to get 180 out of 180. There's no option. Write it, write it. If there is anybody who says, okay, sir, here I am just thinking over it, I'm not doing anything, I might not do it, better leave the class. I already have only 7 students. If I have only 1 student, that also is okay. Doesn't make much of the difference. Example 2.9 also. Any confusion in any of these examples? If anything you want to ask, go ahead and ask it. What's so funny, Ananya? Great, done. 2.7, 2.8, 2.9. No confusion in any of these examples? You have to write it. Just don't copy it. You have to write it and understand it, what each of these symbols mean and why you wrote this. Okay, we have in-text questions. You have to write the answer of these in-text questions, search it from the NCERT. You are not supposed to get these answers from the internet. You have to search it from the NCERT, write it down and send it to me. 2.9 wala explain करूं प्रेरणा. The conductivity is given. No, no, this is the concentration. This is the conductivity. The conductivity is kappa. This is the concentration. This is the dissociation constant of lambda not m. Now, lambda m is equal to kappa by concentration. Prerna, is that clear? So this is kappa, this is the concentration, and we need a conversion factor. This is the conversion factor. In this conversion factor, we have converted into mole. And now, there is a mistake. This is going to be centimeter square, not centimeter cube. There's a misprint in NCERT. This will be centimeter square. Okay, this is centimeter inverse, this is centimeter cube, so this is going to be centimeter square. That is our mistake here. Okay, and that mistake has been rectified here. You can see that. Clear? So we are able to find lambda m, and lambda not m is given to you. So lambda m upon lambda not m is alpha. That's 1.233. And there we have just used the equation and substituted. This is the equation. Prerna, is it now okay? These 3 questions you are going to solve it on your own and send it to me. Okay? And each of you has to see the answer sent by other people. If they have committed a mistake, you have to inform them. Okay? So not only you have to do your own question, you have to read the questions of others as well. Just one person more, anyone. So this is what we have as the conductance. These are few questions of conductance. And then you are going to do the back questions as well. Here, 2.7, 2.8, 2.9. These are the questions, these are the homework for you. This one, 2.11. Okay? Clear? These are the questions you are going to do. Fine. So we are ending this session now. Okay. Yes, you have to do. 2.11, 2.10, 2.9, 2.8, 2.7. These are the questions you are going to do before the next class that is going to be at 4 p.m. So, I believe you are going to have the class at 2 p.m. now. खा लो कुछ, थोड़ा सा आराम कर लो और अगली क्लास में चलो. Bye bye, take care. Let's have the next class. Okay. 4 p.m. you have the session again. Remember that.